Welcome back to my channel. Welcome back to my video today. A video about Formula 1 and a video, technical video about some ideas, and let's just go into it. So in the new Formula 1, new engine rules, new aero rules, etc., there's talk about Mercedes doing something to increase the compression ratio from 1:16 to 1:18. And a lot of people are speculating they are doing that with the rod and the piston. And in this video, I will show you why I believe that this is not the way they're doing it, and they're doing it actually in a different way. So to explain why I believe that they're doing it this way, let's go into how a normal 4-stroke engine works. So the normal principle is that you have obviously your crankshaft, your rod, and your piston. The rod is off-center, mounted on the crankshaft. So as the crankshafts rotate, the piston moves up and down. And as it moves up and down, you have 4 strokes. You have the intake stroke, where it takes in air. Then you have the compression stroke, where it compresses the air and the fuel mixture. Then you have the combustion stroke, where the piston is forced down. And then you have the exhaust stroke, where the exhaust gases are pushed out of the cylinder. Out of the combustion chamber, basically. And to allow these air flows and fuel mixture flows, you have valves that open and close, etc. If you are looking to increase the compression, then the theory that they are floating right now is that they are lengthening the rod by choosing a certain material that will, under a high temperature, will increase in length. Everything increases or decreases, but some increase more than others. So for example, aluminium increases more in length at higher temperatures than steel would, for example. So if you would choose aluminium, you would get a slightly longer rod than when you would choose a steel rod. Now we're talking fractions of a millimeters here, but with a compression this high, a fraction of a millimeter is everything you need to get more compression out of it. So the point here that I think is a little bit silly is that if you would do it this way, you would create a scenario where you do increase the height on the piston and you do increase the length on the rod by careful engineering. However, the point is that you are not only increasing the height and therefore reducing the space in the combustion chamber, aka increasing your combustion ratio. However, you also have this increased height on your, let's say, your intake stroke. So that means your piston is higher, your rod is longer, and so there's less volume above your piston. So it means that a Formula 1 engine runs a 1.6 liter engine, and that is based on the volume above the cylinder for all 6 cylinders together. So now if you reduce that height above the cylinder, we're now not talking about a 1.6 liter engine, we're now talking about a 1.55 liter engine, for example. So that would mean that the compression doesn't change because you reduce the volume equal to what it was before. So in my opinion, this doesn't make sense at all. However, if you would then add the same amount of fuel, then you would have a slight overfueling, so adding more volume of fuel into the combustion chamber, and fuel is much less compressible than air. So in theory, with doing that, you would then increase the compression ratio by adding the fuel mixture. However, a few things there that I don't believe are true, because currently there's quite a high water percentage in the fuel, and obviously water is much heavier than fuel. So I think I know water is 1,000 kilograms per 1,000 liter of water, whereas fuel is somewhere in the range of 770 kilograms for 1,000 liters of fuel. However, like air, if you change the temperature of the fuel, you can increase the density. So if you were, for example, be able to bring the temperature of your fuel down to 10 degrees, you might get a higher weight of the fuel. And therefore, you can put more fuel in a smaller package, and therefore you would reduce the center of gravity. So if they have active cooling on the fuel to reduce the size of the fuel mass, then I could get into it. However, I believe that they would then also add more water for cooling purposes, because you're running a higher compression ratio. So for example, you would start the race with 1 kilogram of additional weight in water to just have more volume of fuel mixture, not so much actual fuel, but a mixture, just to fill the combustion chamber to get a higher compression ratio. But again, because water is more heavy, if you have to increase the weight by adding more water, I don't think that's the way. So what I believe you actually want to really gain a lot of power is that you want the crankshaft to slightly move. And I believe that for a Formula One team, this is actually quite simple to do. So what do? In my opinion, they make a tiny slotted hole where the rod is mounted. And what that allows the rod to do is move slightly out of center. So let's say they make a tiny slotted hole and they fill it with oil, like on a shock absorber on your road car. A shock absorber on a road car will have tiny holes at the bottom that allow the oil to go through. So certain holes allow a certain oil flow, and they are playing around with a shock absorber where, for example, on a straight road, you would allow quite a lot of oil to go through so that the ride is really comfortable. But then in corners, the holes change so that the car becomes really stiff, so that you can have really nice, sharp turn-in characteristics. I know for a fact that Intrac Suspension, a Dutch company, is doing this for Formula One teams, for example. And they've done this for a very long time. So now, if you look at a crankshaft, it rotates, and obviously it spins at up to 15,000 RPM. So it's a very high RPM, so it's a lot of force. So just the way the crankshafts work, the centrifugal force wants to move the rod outwards. So if you have an oil chamber that, for example, at 3,000 RPM has so much centrifugal force that the oil is pushed out, it would allow the rod pickup point to move outwards 1 millimeter, for example, just by the centrifugal force. So if the car accelerates, you get the crankshaft position for the rod 1 millimeter out, all the way around the stroke of the crankshaft, let's say, or the rotation, I should say. And what it does is that at the top dead end, you'll get 1 millimeter more of compression, which will give you the 1.8 or the 1 to 18 compression ratio. However, at the bottom end, it would also give you 1 millimeter more volume to fill. So that would then move your compression to 1 to 20. So obviously it might not be a millimeter, it might be half a millimeter or whatever. But the point is that if you look at the rod and the piston, you will decrease the volume above the cylinder, and therefore the gain that you have will just be the added fuel mixture if you're doing that. But basically you're making your engine volume smaller. So I don't think that that's the way to go. However, if you go with a crankshaft that can move slightly under high pressure from the centrifugal forces, then you can increase your volume above your cylinder and decrease the size in your combustion chamber, having a double effect of a change in compression ratio. And I believe that that is way more likely. And especially because Formula One teams will most probably run, let's say, a starving engine. So you can, normal engines run on road cars, they run on lambda 1. Lambda is your ideal ratio between fuel and air. And the reason that you're doing that is because it will give you the best emissions. However, older cars that were running open loop with carburetors and so on, they would prefer to run a little bit lean. So for example, a lambda of 0.95. Why? Because it would give you more power. Diesel engines, for example, they would run on lambda 1.2 at some points, because it would make them much more fuel efficient. But due to new exhaust regulations, that has been changed and they have to run at lambda 1 to get the best emissions. However, a race car obviously doesn't have to comply with that. So if they run a fuel mixture that is lambda 1, for example, at the normal compression ratio, it would run lean when you can put more volume above the piston and have higher compression ratio as well. So in my opinion, that would be the best way. It would be a tremendous gain. And it would, I think, for a Formula One team be actually quite easy. So yeah, that's my theory. Let me know what you think.